Okay, so we're going to put this all together, the four-step process. What is the four-step process for calculating a confidence interval? What do you need to do for each step? Do you always have to do the four steps? Okay, first step, state. We've seen these before. What parameter do you want to estimate and at what confidence level? Plan. Identify the appropriate inference method and check conditions. Do. If conditions are met, perform the calculations. And conclude. Interpret your interval in the context of the problem. Do you have to do it? Yes. That's for both me and Ms. Hines and the AP test. These steps were carefully designed based on the scoring rubrics for confidence intervals. Questions on for confidence. Start that again. Yes, you do. These steps were carefully designed based on the scoring rubrics for confidence interval questions on the AP exam. So yes, you have to, and yes, we'll count it off. So do it. All right. AP tip. If a free response question asks you to construct and interpret a confidence interval, you are expected to do the entire four-step process. This includes clearly defining the parameter and checking conditions. Is it okay to use your calculator to calculate the interval? You can use your calculator to compute the confidence interval, but there is a risk involved. If you just give the calculator answer with no work, you'll get either full credit for the do step or no credit. If you do give a calculator answer, be sure to name the procedure, example 1 portion, Z interval. Okay. Here we go. Here's an example. According to an article, San Gabriel Valley Tribune, February 13th, 2003, most people are kissing the right way. That is, according to the study, the majority of couples tilt their head to the right when kissing. In the study, a researcher observed a random sample of 124 couples kissing in various public places and found that 83 divided by 124, or 66.9% of the couples tilted to the right. Construct and interpret a 95% confidence interval for the proportion of couples who tilt their heads to the right when kissing. Okay, so real quick, I want to show you the curve. We're doing 95%. We're looking at this 2.5% or 0.025. Okay, so let's go through our steps. First, we have to do our state. We want to estimate P equal the true proportion of couples who tilt their heads to the right when kissing at the 95% confidence level. Plan. We will use a one sample Z interval for P if the following conditions are satisfied. All right, you know the conditions. Random. The researcher observed a random sample of couples, so yeah, that works. Normal. Our successes are going to give us 83, and our failures 24, and those are both greater than 10, so those are met. And then last of all, independent. The number of couples in the population is at least 10 times 124 equal 1,240. Anyhow, so we know that there's more couples than that in the population. So next is do. And I used inverse norm, 0.025. Remember that interval is 2.5% is the left tail, and 0 being our mean. when it's standardized and 1 standard deviation. And we're going to get a negative 0.9599. So, putting that into our formula, this is we're going to use 1.96 for the negative 1.9599. Fill in the blanks there. And when we're done, it gives us 0.669 plus or minus 0.083, which gives us 0.669 plus or minus 0.083, which is the interval from 0.586 to 0.752. So the last thing we do is conclude. We are 95% confident that the interval from 0.586 to 0.752 captures the true proportion of couples who tilt their heads to the right when kissing. Exciting. All right. So, AP tip. If you include confidence interval calculations using the formula and using the calculator and the answers don't agree, these will be considered parallel solutions, and you will be scored on the worst response. To avoid this, follow the 4-step process and use your calculator to check your work. Alright, so again, read these pages, and we are choosing the sample size. How do we decide what size sample to choose? What is the formula for the margin of error for a confidence interval for a proportion? Is this formula on the formula sheet? Okay, there it is. The margin of error is equal to your z star times the square root of p hat times 1 minus p hat all over n. Now, that looks real familiar, doesn't it? That's a good thing it is, because this is not on the formula sheet. But the general formula for a confidence interval and the formula for the standard deviation of the p hat statistics are included. So you just have to know this. All right? How do we choose the value for solving the sample, when solving for a sample size? Sorry, let me repeat that. How do we choose the value for when solving for a sample size? All right? Okay. To determine the sample size n that will yield a level C confidence interval for a population proportion P with a maximum margin of error, ME, solve the following inequality for n. All right? So here is our inequality. So we want the margin of error to be greater than this value. All right? Greater than or equal to. Where p hat is a guessed value for the sample proportion. The margin of error will always be less than or equal to ME if you take the guess p hat to be 0.5. Okay, so we usually use p hat as 0.5. All right, so here we go. Suppose you wanted to estimate P equals the true proportion of students at your school who have a tattoo with 98% confidence and a margin of error of no more than 10%. How many students should you survey? All right. Well, the problem is determine how many students should be surveyed to estimate P within 0.10 with a 98% confidence. Our solution, okay? Since we don't have any previous knowledge of the proportion of students with a tattoo, we'll use p hat equal 0.5 to estimate the sample size needed. All right? Here's our formula. Now, they showed it in the book a little bit different. I just worked it out mathematically and divided by both sides by 2.33 and squared them. And then I moved the n over here by multiplication and then divided that whole thing, this whole thing, by 0.10 divided by 2.33 quantity squared. And I got this, that solving this, we get n is greater than 135.72. So we need to survey at least 136 students to estimate the true proportion of students with a tattoo with 95% confidence and a margin of error of at most 0.10.